So test number 3, I forgot when it is, but next time I will know. But it's in the syllabus, I just forgot. It will be, I think it's supposed to be a Monday or a Wednesday. It will be in online. Okay, so that day we won't have class and you will take the test online. I will open it for like 2 hours, and the class before I will tell you what to expect as usual, right? And then remember the final, it's being pushed on us, so I cannot change the date. It should be the Monday of the final week. And it will start at 10. It says 9:45, but 10 a.m. is fine. And it's not cumulative, and it's 20% of your final grade. And I have a nice grading scheme, so it's not should not be that hard to get a good grade. Any question on that? Keep track of your assignments. I have to check tonight if for the assignment for next week. Okay, so now we are talking about the solar system. So we talked about the inner planet, and then here we will talk about the inner planets. And then here between Mars and Jupiter, you have the asteroid belt, but you have other asteroids at different locations, but most of them will be located here. And then you have the gaseous planet, mostly made of hydrogen and helium. Okay, so terrestrial planets. So I'm skimming through because if you want to learn more, there is another class that will focus on the solar system. I think it's also an introductory class, right? So it gives you credits for a science class. So anyway, you see the rocky planets here. So you have Mercury, Venus, Earth, Mars. Mars can be seen, right? Right now, it's such a wonderful time to observe the sky because you can see Orion, you can see Mars. By the way, for the blood moon, even with a nice camera, you could take a picture of the blood moon. Okay, my son did it, and you could see the moon, full moon, all red. Okay, and next to it, you could see Mars, which is like a red dot. So it was a great time. If you like to take pictures, it was a great time. And so it was called the the blood moon, the blood moon. Why is that? It's a it's a solar eclipse. No, it's not a solar eclipse. It's a lunar eclipse. I don't know if I have a picture somewhere. Uh, I have so many things here. I cannot even find my pictures. Mm, okay, that's what happened last week. You see, that means the Earth is between the sun and the moon. So the light from the sun interact with the Earth atmosphere. So it's going to scatter the blue wavelength, and what will be left here will be red. So that's why you have a blood moon. And it was easily seen from Miami, even though you have so much light pollution. And I even have a nice, but I just have to find it. I have a nice simulation, but of course, this one. Okay, so it's called, so if I ask you a blood moon, when that happens, it happens during a lunar eclipse. So it's like the moon is eclipsed by the Earth. The Earth goes between the sun and the moon. I did send you like an announcement. That's what happened here, right? You see how it gets red? It's a very nice simulation. So that's what happened. It only happened 2 to 4 times a year. And especially it was great. Last week was great because we didn't have so many clouds. And okay, so again, that's what's happening here if you are interested. And again, even if you have an interview, if you say, oh, I'm chasing after lunar eclipse and I take beautiful pictures, it will impress, right? So you see the moon here, the earth is between the sun and the moon. This part here is called the umbra, and the earth is going this way around the sun, and it's even cast a shadow on the moon. And back then, at the time of the Greek, they even used that shadow to measure the size of the earth, because they were very good at geometry. Okay, so that was super cool. In addition to that, we have a great news. The astronaut who are stuck, which is ridiculous, since June 2024, they're going to be free, like by Elon Musk sent SpaceX, I think. So it was in the news. So they will be brought back to Earth because Boeing failed to bring them back. So I have no idea why it took so long, but I will not be happy, especially because I'm claustrophobe. So anyway, that's a good news. I'm happy for them. So anyway, so these are the planets here, inner planets. You see they are dense. Most of them are quite dense if you compare that to the giant planets. So let's see if we have, um, so the formation here at the beginning of the formation of the solar system, what we think happened is that in that cloud of dust and gas, so it started to spin, right? In this direction, it will collapse, so it will make a disk, but in this direction, all the dust and gas and the new planets were in equilibrium between gravity pulling in, centrifugal force pulling out, right? But at the center, it will spin very, very fast because of conservation of spin. So we talked about that. So how did do they think that the planets got into formation? You have little dust, right? Clumping together, sticking to each other because of gravity. So it made those larger pieces here, so 1 kilometer wide, and they are called planetesimals, right? So they started to come together because of gravity, right? So they will come together, and because when something falls, right? So it's they are falling toward each other. When something falls, it's going to release energy. That energy here was released as heat, so it was very, very hot. So things started to melt, and because it was in the liquid form or molten, uh, the heavy stuff sink inside, so that will be the iron core. So most of the inner planets do have an iron core, and here you have the crust around, so not as dense. In addition to that, you have a lot of radioactive isotopes like thorium, potassium, uranium that decay and provide enough heat for melting to happen. Isn't that cool? Okay, so here you have so that's an old slide, but still you can compare all the planets, and if you look at the density here, right? If you look at the density, you see that the denser planet will be the Earth because it has a lot of iron, which is a dense metal, right? So it has an inner core, an outer core, it has the mantle and the crust. So you see it's very dense. Now, can you see which one has a density less than 1? Saturn, yes, right? What's your name? Nicole. Yes, exactly. Saturn has a density less than 1. What does it mean? It means if you had an ocean large enough and you put Saturn in that ocean, it will float. It will not sink. And maybe it will have, because it has rings, like it will be like a buoyant uh, device around Saturn, but it will float. So if I ask you, what planet will float if you have a big enough ocean, that will be Saturn. Now, you can look at the mass here compared to Earth. So the Earth here has a mass of 1. You see that the more massive planet will be Jupiter. Okay, so 300 times more massive than the Earth. And it's also the larger planet. You see, you can compare the size between Jupiter and Earth. You see that you can put 10 Earth across Jupiter. And you can put 10 Jupiter across the Sun. Okay, so here it's nice because you can compare the size. Here you have the distance from the Sun. So Earth, Sun is 1 astronomical unit, so that will be 1. You see Jupiter, it's 5. So if this is Sun, Earth, Jupiter will be 1, 2, 3, 4, 5. So you can build a solar system on scale if you respect those ratios, right? You can do that for extra credit, art and craft, right? That will be cool. I used to do that with students in lab. Okay. What else? We can look at the density. So that will be how long does it take to go around the sun? And remember, all the planets go counterclockwise. Okay? They all go counterclockwise, no exception. But they also have a spin. Okay. So all of the planets spin counterclockwise except Venus spin clockwise, and Uranus likes to roll on its side like a barrel. I don't know if I have a picture here for you. If you have any question, let me know. Spin here. You see Uranus is rolling and all the other planet goes counterclockwise. We go counterclockwise, and Venus is the weirdo. It decided that it doesn't want to spin like the other planet, so it's spinning clockwise. And they all have a tilt. Most of them have a tilt, more or less. So remember here we have a tilt of about 20 degrees. That's why it's hot during the summer, because we are tilted. The northern hemisphere is tilted toward the sun, so we can get more heat from the sun. Okay, so here we have the tilt. Pluto is tilted a lot. Axis tilt. So temperature is interesting. You see Mercury is horrible. Mercury is horrible because it does not have an atmosphere. Okay, so we do have an atmosphere that keeps us just warm. Okay, our temperature on Earth is about 60 Fahrenheit, 15 degrees Celsius, which is great for life to evolve. And plus, we have amazing negative feedback. So if it gets too hot, there is some mechanism to make it cooler. If there is too much CO2, carbon dioxide, you have a negative feedback to take that carbon dioxide into the crust. So we are full of negative feedback. So it's like if you are in biology or you are interested in how the human body works, we also have negative feedback. So if it's very hot outside, we have a mechanism to cool us down. We sweat, the blood vessels get dilation of the blood vessels. And if it's too cold is the opposite, right? Well, the blood vessel will contract. So we have negative feedback, and it's called homeostasis. So the human body try to find the right balance. So if there is too much of anything, it will try to decrease it, unless we are broken, which happens, right? So too much stress, too much cortisol, then we have another hormone to bring it down. If we have too much sugar in the blood, you have insulin, because sugar is very toxic. So The body wants to make sure you do not have too much sugar in the blood, so you have insulin taking the sugar, putting it back away in the fat storage. So the earth works the same way. Okay, it has negative loops, negative feedback. But Mercury here, or Venus, it's hell. You see, Mercury does not have an atmosphere, so during the day it's going to be 800 Fahrenheit. So when it's facing the Earth, the temperature will be 800 Fahrenheit. Okay, you don't want to be. I mean, you cannot even survive 1 second with 800 Fahrenheit. Yeah, you disappear. Um, and then at night, it's the opposite. At night, it means when it's facing one face is away from the sun, the temperature is going to be like minus 280 Fahrenheit. Okay, minus 280 Fahrenheit. So you cannot live, you cannot survive. Life cannot survive over there. And Venus is very bad as well because Venus has a positive feedback. So it's like a runaway greenhouse effect. So when people say hell is inside the earth, right? When I was a kid, they would all say, oh, hell is inside the earth, somewhere, and heaven is in the sky. But actually, I claim that hell should be on Venus. It may be on Venus, right? They send people over there because look at that, 800 Fahrenheit. 800 Fahrenheit all day long, all year long. Okay? It's really bad. So the Earth, perfect. 60 Fahrenheit, 15 degrees Celsius, negative feedback. So it's always easier to survive when it's hot, by the way, than when it's too cold. If you look at history, people have been struggling to survive when you have mini ice age, like in the Middle Age. People will starve to death. But when it's warmer, it's easier, right? You don't have as many deaths, by the way. So Mars here, still cool. It has an atmosphere, but it's going to be very, very thin. We think that Mars maybe had oxygen, but it could not retain that oxygen in the air. Okay, and then you have the big planets here where it's all cold. Okay, so that will be how long does it take to rotate? You see, Mars takes about 20, Earth, where is Earth? 24 hours. Okay, it takes 24 hours for a day. And then this one, Venus, 243 days, Earth days to go around its axis, right? So you see how Jupiter spin really fast, about 10 hours. Okay, so it's you start your day and it's already done. You have no time to do anything. 10 hours only versus 24 hours on Earth. And then, so that's a whole slide. And you see the moons. Why do I say that it's a old slide? Because they keep finding new moons. So for example, Neptune here had 13 moons. Now we know it has 16 moons. And then Jupiter here, I don't know, it's how old, maybe 2010, like 10 years ago, 63 moons, and now it has 95 moons, right? So as we improve the way we have to check on the planets, to send spacecraft, to improve the telescopes, we find new moons. But the only moon that has an uppercase, which is our moon. So it's called the moon with uppercase, right? It's because it's special, it belongs to us. So I don't know if I have a picture of all those moons here. You can see the sizes, right? So these are 1, 2, 3, 4 large moons of Jupiter. So they are called Galilean moons because they were spotted the first time by Galileo. This is the moon, right? Our moon. It has an uppercase. It doesn't even have a name. It's the moon. Then you have the other moons there. And you see very diverse in size. Europa is also belongs to Jupiter. So Jupiter, okay, I go back. Jupiter, you have 1, 2, 3, 4. Titan is Saturn. Okay. So I'm just skimming through here. I forgot to show you last time. I found also a small video here. Okay, it's 6 minutes. Okay.
This is the story of our Earth's formation 4.5 billion years ago, and of a little asteroid called Bennu, who's also survived until now. We have the team at NASA to thank for bringing us this video.
The Milky Way, home to billions of stars, rising and setting over billions of worlds, including our own. In this vast expanse, how did our sun, the Earth, and the planets come to be? In recent decades, our understanding of the solar system's evolution has greatly improved, but deep questions remain. To answer those questions, astronomers are preparing to visit someplace very small. Asteroid Bennu. A lump of rock and organic material, the early building blocks of the solar system, of Earth, of us. Capsule, and its journey takes us way back, 4.5 billion years. The raw ingredients of Bennu and our solar system originated in a stellar nursery, a vast cloud of hydrogen, helium, and dust. Our own sun doesn't yet exist. Nearby are hot stars like this one, quickly burning up its fuel and destroying itself in a colossal explosion called a supernova.
So remember that we talked about that, right? It all started with supernova. So there is a massive star collapsing, and then there is a rebound, so explosion in a supernova. And inside the supernova, that's where all the heavy metals will be cooked, like iron, uranium, all those heavy stuff, right? And that will be recycled into our Earth and other planets and the sun. So we are supernova dust.
The explosion destabilizes our cloud, causing it to collapse. In the geologic blink of an eye, 100,000 years, gravity and angular momentum flatten the cloud into a swirling disk. In the center, where molecules crash together tightest, a protostar revs up to incredible pressures and temperatures. Deep within the disk, clumps of dust not much larger than a grain of wheat are flash heated into droplets of molten rock, called chondrules. The source of this heat remains a mystery. Chondrules are destined to become the building blocks of the solar system. Coaxed by gravity and turbulence, the chondrules clump. They grow into the first asteroids, into mountains, into planets. The asteroids are rubble piles of rock, metal, ice, and organics. This large asteroid is the parent body of Bennu, a protoplanet whose size we can only guess. Closer to the protostar, a planet begins to form. And then, dawn in the solar system. The protostar undergoes fusion and ignites, revealing our sun. But the solar system is far from finished. Jupiter most likely forms near its outer edge, but just 500 million years after the sun ignites, some believe that it slowly moves inward. Its massive gravity ripples the asteroid belt, disrupting countless asteroids and comets, flinging them toward the sun. They rain down on the inner planets, hammering and remelting large portions of their crust. Did these impacts also deliver organics and water, key ingredients for life? Back in the asteroid belt, Bennu's parent body is lucky. It survives this period of heavy bombardment. The solar system cools and calms. Jupiter and its many moons assume the orbits that we see today. Billions of years of quiet follow, more or less. Then a billion years ago, one theory suggests a collision shatters the protoplanet. Some of the debris loosely coalesces into a new, smaller body, Bennu. But Bennu will not stay in place. Dull, non-reflective, it slowly migrates toward the sun. Solar heating turns its warm side into a low-intensity thruster. Through millions of years, Bennu's orbit gradually tightens until it interacts with Saturn's gravity, altering its trajectory and hurling it into the inner solar system. Close encounters with Earth and Venus follow. Their gravitational tugs may have repeatedly stretched and reformed Bennu, turning it inside out and pulling off loose material. As a result, it has no satellites of its own, until now. Today, NASA is sending a spacecraft called OSIRIS-REx to explore Bennu and retrieve a sample. Why? Bennu has survived its long journey and settled into a near-Earth orbit, bringing its secrets within our reach. Now it is ready to teach us more about the solar system's history, its formation, its evolution, and our own place among the stars.
Okay, so it's a nice small video. Okay, so let's keep going. So let's talk about the Earth first, right? So you all know the Earth has, maybe I have like a picture of that, the Earth here. So you have a slice in 3D. So it has an inner core, which is believed to be solid because all the pressure pushing, even though it's very hot here, it's still solid because the pressure from the weight, from everything else here, push it and prevent it to go into liquid phase. And then you have a molten outer core. Okay, so inside that core, you have like ions, okay, so like metal ions that move. You have a lot of motion inside, and then you have the mantle, and then you have the crust here, the lithosphere, and here. So asthenosphere is part of the mantle, so upper mantle, but here you see it's a crust, and the crust is broken into tectonic plates. I'm sure you heard about it. So those plates, they can slide past each other, like you have in California, Sant Andreas Fault, right? So it means it can slice. So first it gets hooked together, right? So energy is building up, potential is building up, and then boom, it can let go. And that's when you have an earthquakes. Or you can have two plates, like in the Ring of Fire around the Pacific Ocean. You can have like the Pacific plate going under South America, and that's why you have volcanoes over there. So you can have a plate going under the other one. So it's very dynamic, which means the Earth is very much alive. It has earthquakes, things are moving here very slowly, but they do have some motion that will take one plate and to push it under the other one. So if you have motion happening, that means you need to have a source of energy. And the source of energy, so typical pop quiz question, because even ChatGPT might not know it, right? Although it's not a good idea to use ChatGPT so much because when you're going to have your real job, right? And I'm not sure you can use AI so much. At some point, they won't let people use AI so much. So anyway, my point is that the source for heat here is radioactivity. Okay, few people know that, but it's because you have so much radioisotopes inside the crust. Those radioisotopes will decay. You have thorium, potassium, uranium, and it will release heat. And that heat is why the Earth is so dynamic, right? So it's alive. We can say that. Okay. And then we are also gifted with a magnetic field. So the Earth has a magnetic field, most planets do. And this magnetic field here will protect us against cosmic rays, right? Like especially coming from the sun. The sun has some solar wind. It can be made of nasty particles like protons and electrons, and you don't want to be exposed to them, right? It can cause cancer, it can be nasty. So lucky for us, we have like a shield. So this is like a shield, right? Protecting us from those cosmic rays. You still have cosmic rays, reaching the Earth, but that will be limiting the amount of cosmic rays we get. Like every second through your brain, you have cosmic rays going through your brain, but we have evolved in such a way that it's not going to harm us so much, but that will be really limiting the amount of particles. So I don't know if I have like a picture here. You can see all those nasty particles here, cosmic rays or solar wind. And this is the magnetic field, and it protects us against it. And that's why if you go in space, so we will talk about the space race during the Cold War. So Cold War started after World War II and it ended in 1990. So I was a student at the time, so it was a big deal. So anyway, during the Cold War, there was a race between the Soviet Union and the US. And mostly it was always the Soviet Union first. They were the first to send a spacecraft in space. They were the first to send a living thing in space. They were the first to send a man in space, a woman in space, right? But the US also was making some discoveries. In particular, they discovered what we call the Van Allen belt. So you see those particles coming from space interact with this magnetic field. Those particles will accelerate around those magnetic field lines and it will burp out beautiful light. Okay? Ultimately, we were the first one to reach the moon. Not to reach the moon. That was also the Soviet Union, but we were the first one to have a man on the moon. But that will be for another. It's another story. It's coming up. But now you see those places. Can you see the places where you do not have a magnetic field? Too much of it. It's at the North Pole and the South Pole. That's why we have the northern light. It's the particles coming from space interacting with the atmosphere here and burping out beautiful light. I don't know if I have a picture that was taken. You know, you don't even need a pair of binocular, right? If you want to take beautiful pictures, a good camera is like a telescope. So that will work too. Okay, everything is a mess, northern light. I will show you. Now, I just want to show you something else because this is what I'm teaching right now. Because I'm a physics professor, okay? That's why I like physics. I'm just teaching this. This is the topic right now. So I have this great app and it's going to show you here. You see, you have the Earth, you have the magnetic field, and you have all those particles, charged particles coming from space that can harm life on Earth. But when it's trying to reach the Earth, look what's going to happen. It's going to be trapped. It's being trapped. So it's being forced to curl around the magnetic field. It's going to accelerate. And when it's going to accelerate, it's losing energy. It's going to radiate. You're going to have radiation light. It's going to burp out light, right? That's why we have the northern light here. So that's another view. Isn't that cool? So everything has been designed for life to be possible on Earth. So again, you see, you have the solar wind with all those nasty particles interacting with the magnetic field of the Earth and to keep us safe. Now at the poles, right, you're gonna have aurora borealis with beautiful, amazing display. This is amazing. If you go north, you can see them, take pictures of them. So how come we have a magnetic field? It's as you all know, um, a magnetic field is being produced, for example, by a permanent magnet. So magnet has a north and a south. A compass, okay, a compass is just a magnet as well. It has a north and a south. So you see, north and south attract each other. This is south, this is north, right? And then you go on the other side, this is north, this is south. So north attracts south. And you all know that on Earth, that will point to the geographic north. But that doesn't make sense, right? What does it mean? Because north, the magnetic north, is attracted by the magnetic south. So the only explanation is that everything happens that inside the Earth, so typical pop quiz question, inside the Earth, everything happens like you have a bar magnet, but the magnetic south is at the geographic north. So that's why your compass, okay, so you have this pole, that will be the north pole of your compass, is attracted to the geographic north. Surprisingly, everyone should know that, but not everyone knows that, right? So now if I do that, you see you have the south attracted to the magnetic north. So this is the geographic south, but it's a magnetic north. Of course, if you dig inside the earth, you are not going to find a bar magnet. So how can we explain that? It's because the source for magnetism is actually electricity. So when you have electricity, like an electromagnet, okay, it's electricity flowing, an electromagnet will behave like a magnet. So how can we explain that the Earth behaves like a bar magnet? This is because in the outer core of the Earth, remember it's liquid, it has ions, so charged particles that move, and that will create a magnetic field. So that's the source of the magnetic field of the Earth. What is surprising is that every million years it's flip. We don't understand why. It just decides to flip. So everything starts to loop around in the opposite direction. So the magnetic field will flip. During that time, we are not protected anymore, right? So there was a lot of discussions about that. Maybe that give like a kick for life to evolve, right? Maybe destroy life. We are not sure. So if you are interested, you can look into it more. Any question? So how do we know that it flipped? Because if you look at the lava from volcanoes that got frozen, the lava has like small magnetite. It's like small compass, small magnet. And then it gets solidified and it's frozen. And those little magnets shows you that the geographic north used to be the geographic, the magnetic north, right? So that it means that at the geographic north, you had like a north pole and then it flipped. So that's how we know. So Van Allen, okay. Okay, let's talk about the Earth a little bit more, just show you nice pictures that I have gathered. You will have the only astronomy class with so many videos and pictures that I'm gathering. Okay, so this is Earth from space. I think this is the International Space Station. What is amazing about this picture, you see how thin the atmosphere is, the blanket. And it's just the right size and the right composition for life to happen, right? So you see the space station here going in orbit around the sun. So there is a picture of, I don't know if you look at that in the news, SpaceX docking to the International Space Station to save those astronauts who have been stuck for so many months. It's not very healthy because they cannot work on their muscles or bones. So it's like having accelerated osteoporosis. Okay, so it's not very nice. But my point is there was a joke because someone was welcoming the SpaceX uh, people coming in with a mask of alien. So they like to disguise themselves. So that was very cool. It's in the news. Oh, that's also very nice. You see, Earth has also the right gravity for us to be able to move around and not be crawling around. Because if gravity is too strong, we will not be able to lift ourselves. So gravity is perfect, or our body is perfect for gravity, because that way we can work on our bones, right, to make them stronger. Maybe we evolved that way, I don't know, but it has the right gravity. So that will be on Earth. You see, you can jump, and different planet has different. You can't, right? It's the gravity is so strong. Neptune also very strong. Venus, oops, it don't go very high. Mars, you jump higher, right? Twice as high as the Earth. Moon, even better. That would be so cool. 2 meters. Pluto, watch out, you're gonna go really high. So Ceres is asteroid. So some of them you have to watch out because if you jump, you don't come back because the mass is not enough to bring you back. Okay, so when you jump, you have enough kinetic energy to escape gravity. So it's called the escape speed. That's the moon. Oh, you boy. Still going up. That Phobos is Mars moon. Oh, I don't know if you will be back. You are not back. Are you back? Oh, sun. No, forget it. Okay, it's a nice simulation. Okay, so this is very, very cool. Okay, you can do that with a telescope. So the idea, you can program telescope to aim always at the same point in space. So you can actually see the rotation of the Earth. Isn't that cool? Right? So it's aiming at the Milky Way. So the telescope is changing over time because there is a software to make it stare at the same points in the sky, and you can visualize Earth rotation. You are so lucky that you don't realize how lucky you are. Even when I was your age, that was not that long ago in the 80s, right? We didn't have access to that. We had to go to the library. There was a thing called the library, and we had to open book. And even though with the books, it was very hard to visualize. But you are very lucky to have all that. What else? Earth rotation, another one. Super cool. So maybe it's from Hawaii. Beautiful, amazing. You see the day and the night, and you can really see the Earth rotation. I hope you can see it here. Otherwise, you can see it there. I don't know if the resolution is pretty good there. Okay, and water. So that's why it's called the blue planet, right? So if you take all the water from the ocean, that will be it. So not much compared to the size of the Earth. That will be the freshwater, lakes and river, right? But it's spread out. So from space, it looks like the blue planet. Super cool simulation. I love those. So let's talk about the moon now. So 1969, we were the first one to reach the moon. Not the first one to reach the moon. That was the Soviet Union. But the first one to put a rover on the moon was the Russian. But we were the first one to have men on the moon. Happened in 1969. So interestingly, if you are interested in politics, because so far you still had a Cold War recently, but here you have all the achievement, right? So here you have the US and here you have the Soviet Union. So it was a race. Okay, I do this, I'm going to do that. I do this, I'm going to do that. I do this, I'm going to do that, right? So first, it was always the Soviet Union first. And this I remember because that made me cry when when I was young to heard about that story. I was not born, okay, I'm not that old, but the Russians were the first one to put a living thing in space. Its name, it was a female. Its name was Laika. It was a very small dog, you know, the very small dog, very smart, and it didn't come back. I thought that was so sad. You can Google it, okay? You can Google Laika to see what she looked like. And then the US, they sent a chimpanzee in space. So I don't know if it made it back or not, right? And then they had the first flyby, okay, by the moon. Okay, the first picture taken of the moon. So first, they were always ahead of us. And then you have the first human in space, very famous, Yuri Gagarin. So very famous, right? 1961. And then they sent the first American in space just behind it, right? So 1961, April, 1 month later, it was the American. They were also, so they were also flying by Venus. Okay, so that was the first flyby of a planet. Here, first women. Yes, first women here. Valentina. Okay, I cannot say the last name. Okay, and you see, it kept going like this. And then finally, 1968, the first, 1969 is the first man on the moon. Okay, and because it was too expensive for the Soviet Union, it takes a lot of money, so they didn't have that much money. So then after that, they stopped. Okay, and then the Cold War tapered down in 1998. I think they built together the International Space Station. So that was very nice, right? So they also built the first space station. So few people know, but there is a dark secret behind the Apollo program. So it was a big achievement, right, to go on the moon. So also there was an interesting story. I don't know, did I lost my? Okay, there is a interesting story because they had to pick who will be the first one to set foot on the moon. And Buzz, so you have these three astronauts, and Buzz was picked first, right? So I don't know if Neil Armstrong was upset about it, but conveniently he forgot his camera. So we do not have a picture of Buzz Aldrin walking on the moon, but we do have the picture later for Neil Armstrong. So that's a funny story. So they had this American flag. And if people say, oh, we never been to the moon because look, the flag is standing and there is no atmosphere on the moon, that's because it was rigid, right? I have a friend who believed that we never been on the moon. But anyway, I think we did. You can think whatever you want. So few people know the dark story behind it, right? So there is a website. Dark story is that how that happened, that Apollo program. So the man behind the Apollo program who was certainly an genius, an engineer, and his team were also very, very good. They were actually Nazi. So it means they used to work for Nazi Germany, and his name was Werner von Braun. So very famous because he's the one who built the first ballistic missiles, right, for Germany. He was belonging to the Nazi Germany as well, and he has a dark side, a dark story, because his missiles, right, were also um, responsible for killing thousands of people in Belgium, but also in England. And his missiles were built in concentration camp. Okay, so few people know that. They don't like to talk about it too much. So there is a paper here about it if you're interested. So how come he ended up in the US? After World War II, the US wanted to bring all the brain from Nazi Germany, so they had a special program called Paperclip, the Paperclip program. So gave them like a green pass, right? The green card. And they say, okay, we're going to forget about your past. We are not going to say anything to anyone, but you're going to work for us. So that's how they built the NASA in Huntsville, Alabama. So I went there, to hike because I like to hike in the Appalachian. So Alabama, Huntsville, it's really the beginning of the Appalachian, and then it keeps going. But if you go there, you still find places named after him, like the activity center. It's called Van Braun Activity Center. So anyway, um, so he was the first director of the Apollo program, but because he was a genius, right, he made that possible to reach the moon. He was very smart, obviously, but he was also from the Nazi party. So I don't know. I have nothing to say about it. I'm just giving you the fact, right? But he was not the only scientist that the American brought back to the US. You had also many biologists because, as you all know, the Nazis, they like to do experiments on people and to work on bio warfare and chemical warfare as well. So they brought all those brains into a secret classified program, paperclip program, and now it's disclassified. So it's interesting that achievement was made possible by a Nazi. So I found a website here if you're interested, and it tells you about it. So that's just the dark side. And likewise, the moon has a dark side, meaning we only see always the same face from the Earth. Isn't that a nice segue, right? Transition. I don't know if I have a picture here. I know I have a picture somewhere. Here. We always see the same face, right? Of the moon. Okay. This is because it takes about 27 days for the moon to rotate about its axis, and it takes about 27 days for the moon to go around the Earth. So when this one goes 1/4, the moon is going to rotate 1/4. So it's always the same face looking at the Earth. So this is called the far side or the hidden face of the moon. So we always see the same face. It takes 27 days for the moon to orbit the Earth, and it's locked. Okay, because of gravity, it's locked. So I think that was since, I think it was 2009, and it's still around, right? 2009, there is a orbiter. It's called Reconnaissance Orbiter, and it was launched, and it's still going around the moon, and it's taking beautiful pictures of the moon. So you see here, this is called the mare. Okay, it's just a lava flow, and here it's being bombarded by a lot of projectiles, like asteroids. And because you do not have erosion, you don't have wind, atmosphere, or rain, the impact can be still seen. Whereas on Earth, everything has been wiped out. It's a beautiful picture of the moon. What else about the moon? So we can use Kepler's law to find the mass of the moon, right? So if you have a probe going around the moon into orbit and you know how long it takes to go around, how far you are from the center, you can find the mass of the moon, you know the size of the moon, you can find the density of the moon. Because we talked about Kepler's law. Okay, so this is Maria, right? Heavily craters, no erosion on the moon. So how do they think that the moon was formed? So interestingly, it's like a piece of Earth. So first of all, it's quite big for a moon. So what they think what happened, and the material of the moon is the same as the material of the. So they think that at the beginning of the formation of the solar system, you see there was an impact. So because all that potential energy from gravity, okay, turned into heat. So here it was partially melted, and a piece of Earth became the moon, and it was trapped by gravity. Okay, so that's a theory, and of course you cannot prove it, but that's what they think. Now the size of the moon. So people say actually the moon is really a moon. It's considered as another planet because it's so big. So you can think of the moon and the Earth as a double planet system. They both orbit their common center of mass, except that the center of mass is more inside the Earth, right? But it's still orbiting their center of mass. So you can think of that as a double planet system. So if you want to compare the size, again, we didn't have that technology here. Now we can compare the size. So that will be, if this is the moon, that will be the Earth. See, you can compare the size of the Earth and the moon. So sometimes the moon will appear really, really big. So mostly it's illusion, optical illusion, right? Or it's also sometimes because the moon is very close to the Earth, but it appears giant. So that was from a student, a picture taken in Miami, and this is called the hunter moon. So it's also appearing orange. Why it's called hunter? Because in the fall, people will hunt, and the moon will help them to see. So it was like so that's why it's called a hunter moon, right? At the time, like in September, October, it will be a perfect time to go hunting. Okay, so the trees have lost their leaves, and you could see even better, and it's great for outdoors activities as well. Blood moon. Oh, here is the picture I was looking. Northern light taken in the North Pole. Amazing display. Okay. The phases of the moon depends where you are. So you see here it looks, North Pole looks like this, Northern Hemisphere, equator, the Southern Hemisphere. So you're not going to see the same shape. It depends where you are located, okay? Okay, so we're gonna stop here. Again, test number 3, remind me, I have to give you the date.